The current flowing through an inductor of self-inductance L is continuously increasing. Plot a graph showing the variation of 1. Magnetic flux versus the current. 2. Induced EMF versus di by dt, that is change in current with respect to time. 3. Magnetic potential energy stored versus the current. So from question, okay, we have inductor, okay, we have inductor having self-inductance L, and let I be the current flowing through the inductor. And from question, okay, current I is continuously, it is continuously increasing, okay. So we have this. So the current I flowing through the inductor is changing continuously. Now, case 1, okay, we are asked to plot the graph between magnetic flux versus the current, and we know magnetic flux, okay, is denoted by the symbol phi, and magnetic flux linked with the inductor is directly proportional to current flowing through the inductor, okay. So we have this, and we can write magnetic flux phi equals L times I, where L is the constant of proportionality, okay. This is constant of proportionality called self-inductance, okay. This is self-inductance of the inductor. So we have this. So L is constant. Therefore, from this relation, okay, we find magnetic flux is directly proportional to current. So the plot of magnetic flux and current, okay, I'm showing this, and magnetic flux phi is taken in vertical axis, okay, and current I is taken along horizontal axis. So from this relation, as I said earlier, okay, we find magnetic flux is directly proportional to current. Therefore, the plot is straight line, okay. The plot is straight line. Clear? It is straight line. The plot or the graph between magnetic flux and current is straight line. So we have this. Now, case 2. Plot of induced EMF versus di by dt, and we know induced EMF, let us denote it by symbol EI, equals minus L di by dt. We know this, okay. And in this relation, we find, okay, L is constant, that is self-inductance of the inductor, okay, is constant for a given inductor, okay. Now we find from question, okay, current is continuously, okay, it is continuously increasing. So for continuously increasing current, di by dt is positive. So we have this. Clear? Therefore, induced EMF, okay, I'm writing over here, induced EMF, EI, okay, is negative. So we have this. We can see, okay, from this relation also, induced EMF is negative L di by dt. So di by dt is positive for continuously increasing current. Therefore, induced EMF is taken negative. So we are asked to plot induced EMF versus di by dt. Clear? So I'm taking induced EMF in vertically downward direction since it is negative, okay. So I'm taking induced EMF along this direction, and di by dt along the horizontal direction. Now, for di by dt, okay, so I'm writing over here. For di by dt, okay, increasing at constant rate, okay. The plot of graph is straight line, okay. So we have this. So this is to be noted, okay. So we have this. Clear? For di by dt increasing at constant rate, this is the plot of induced EMF versus di by dt. Now, if I, that is current, is increasing at constant rate, okay. So for this condition, the graph is straight line, okay. The plot of induced EMF with di by dt when I is increasing at constant rate, okay, is this. So the plot or the graph, okay, is this. So we have a straight line, okay, parallel to di by dt. Now, case 3, okay, we are asked to plot magnetic potential energy stored versus the current. And we know magnetic energy stored by the inductor is, okay, that is denoted by symbol UB. This equals half L I square, okay. So this is the relation. Clear? And in this relation, 1 by 2 times L is constant, okay. So this is constant. Therefore, we can write magnetic energy UB is directly proportional to square of the current. And we are asked to plot the graph between magnetic potential energy versus the current, okay. So current is taken along horizontal axis, okay, and magnetic energy stored by the inductor is taken along vertical axis. And the plot, okay, from this relation we can see the plot of magnetic energy stored by inductor versus current is parabolic. So it is parabolic in nature.